Three more homework examples. So I'm going to use implicit differentiation to find dy dx, and then find the tangent line at the given point. First equation, x equals e to the y. So implicit differentiation, differentiate both sides. The derivative of x is 1. The derivative of e, this is a chain rule problem where the outside function is e to the x. The inside function is y. So chain rule says to take the derivative of the outside function, but don't write x. So where x goes, write the inside function. Times the derivative of the inside function, the derivative of y is dy dx. So I need to solve for dy dx, and I get dy dx equals 1 over e to the y. So that's the first part. Another way I could write this as e to the negative y. Negative exponent, a positive exponent, bring up here, make it a negative 1. I'm going to use this form. I'm going to put in a 2 for x. Notice I don't have any x's here, so I don't care about that, but I'm going to put a natural log of 2 in for y. So I get dy dx evaluated at x equals 2 is equal to 1 over e to the natural log of 2. E to the natural log cancels each other out, so I'm left with 2, so I'm left with 1/2, and that is the slope of the tangent line at that point. Second function equation, y squared plus 3x equals 8. Implicit differentiation. Power rule / chain rule says it's 2y dy dx. Derivative of 3x is 3. The derivative of 8 is 0. Solve for dy dx. Subtract 3 from both sides. I get 2y dy dx is equal to negative 3. Divide both sides by 2y. I get dy over dx is equal to negative 3 over 2y. I want to evaluate this when x is 1 and y is the square root of 5. So I get dy dx evaluated when x is equal to 1, y is equal to the square root of 5. Notice that there's no x there, so I get negative 3 over 2 square root of 5. Final example for the first type of homework problems. I have sine of y equals 5x squared minus 4. So chain rule, the outside function is sine of x. The inside function is y. So I take the derivative of the outside function, but don't write x. Where x goes, I write the inside function, times the derivative of the inside function. Derivative of 5x to the 4th is 20x cubed. Derivative of negative 5 is 0. Solving for dy dx, I divide by cosine of y. So I get 20x cubed over cosine of y. I want to evaluate it at the point 1 comma pi. So that means to substitute a 1 in for x and substitute a pi in for y. 1 cubed is 1. 1 times 20 is 20. The cosine of pi is over here on my unit circle, and it's the x-coordinate, so it's negative 1. So the slope of the line tangent to this equation, when x is 1 and y is pi, is negative 20.